Hello students, this is Mr. Estrada. I just want to show you how to graph quadratic functions. And so you need your calculator and this worksheet in front of you that I'm about to give you. We're going to look at different components in finding the quadratic function. We're going to find the vertex, which is either the highest or lowest point in the graph depending upon how it's graphed. The x-intercepts, which is also known as the roots of the solutions. The domain, which means all the x values, and then the range. So the first equation that we have is y equals 3x. So to graph that, all you need is your graphing calculator. Make sure you turn it on. And we're going to type in, like you already see it, I have it already there, 3x squared. And then after you graph it, you're going to press, you can press second and graph to get the table. And you have to scroll up and down so you can be able to see the x value is around 0, -1, and 2, because our window here of how the numbers are located for the x value starts at 0, and then it gradually decreases from there up to -12, and then it goes up to 2. So I'm going to be graphing this, and we were going to check what is a vertex, x-intercepts, the domain, and range. So I have first here 0, 0, 1, 3, -1, 3, 2, 12, and -2, 12. So as you can tell, this is going to be my parabola. Okay, so my vertex here, and this obviously is the lowest point in the graph. This is 0, 0, that's the vertex. That is also known as the x-intercept because it touches the x-axis. Okay, so that's also my x-intercept or my solution. Whether it crosses or it touches the x-axis, that is considered to be my x-intercept or my roots. Now, the domain is going to be all of the x values. And since we have a quadratic or parabola, the parabola uses all the x values. It means all the negative and all the positive numbers. So in that case, the domain is going to be all real numbers. Or another way, if you want to write it as notation, is from -infinity to infinity. And now the range. We have to start from the lowest point in the graph to the highest. The lowest point in the graph is 0. But we have to look at see where this parabola opens. Does it open up or open down? If it's opening up, that means we're going to have a greater than sign. A greater than and equal sign. If it opens down, then it's going to be a less than or equal to sign. So since this is opening up, we're going to say that the range is going to be y has to be greater than or equal to whatever the lowest point of this graph is, and it's that at 0. And we're going to look at 0 as part of the y-axis, so at 0. So y has to be greater than or equal to 0, or if you write this in a notation, it's going to be a bracket because we're including 0 to positive infinity, and we're going to put in the parentheses. Parentheses means it does not stop, it just keeps on going forever. Now there's one more thing I did not mention about this, is the axis of symmetry. The axis of symmetry is the line that cuts the parabola in half. So the axis of symmetry is always the x equals, that's where you start, and x equals whatever is my x value of my vertex. So that means it's going to be x equals 0, and then I'm going to draw my line, the dash line, up and down the y-axis. Alright, so I'm going, that's number 1. I'm going to do number 3 now for you. And number 3 is a different type of quadratic function. Y equals -x squared plus 2x plus 1. And so I'm going to put that in the y equals. So negative x squared is 2x plus 1. And then I can press second graph. And then I want to see if I have two of the same y value. That means I know it's an indication that it's going to be both sides of the parabola. And whatever is not paired up on the y, that is considered to be my vertex. In this case, is my 2. So I'm going to plot the points here. So 0, and then, sorry, I will say 1, comma, 2 here. And then the other one is going to be 2, comma, 1. So remember, when you're plotting it, you always do the x first, so left to right first, and then go up or down after that. So it's positive 2, then a positive 1, so right here. And then I do the same thing for the other one, which is 0, comma, 1. So 0, and then go up 1. Oh, I think I plot the other one wrong. This is supposed to be 1. Cross this out. This is 1, comma, 2. And then I'll do the same thing. 3, comma, negative 2 here. And then negative 1, comma, negative 2 right here. And so here's my parabola. All right. So if that is the case, once I draw it, what will be my vertex? Well, my vertex is the highest point in the graph here. Why is it opening down? Correct. Because my leading coefficient here is a negative. If it's a negative, that means it's going to open down. My vertex is the highest point in the graph, which is going to be 1, comma, 2. What will be the x-intercepts and the roots? Well, you can't really see it just by looking at it. So I'm going to show you the calculator way and how to do it. So to get the x-intercepts and the roots, this is how you do it. You press second and then trace, and we're going to find out the zeros. So we're going to put our arrow at 2, and then there's my parabola. Now, I'm going to use this point right here. This is the left point of the x-intercept. And to get it from your graph, it says left bound and right bound. Well, the left bound is going to be, if I'm focusing on this part here, this one right here, the left bound will be the left side of that point of my x-intercept. And in that case, it's going to be, I'm going to put the cursor anywhere that is below the x-axis. So I'm going to scroll it down where it's below the x-axis. It doesn't matter where you put it. I'm going to press enter. And then I'll do the same thing with the right, but instead of below, it's now going to be above because it's going to be on the right-hand side of this point right here. So I'm going to go to the right, and it doesn't matter where you put it. I'm going to press enter, and you're going to press enter again. So there's my 0. My root is going to be, if I have to round it to the nearest hundredths place, negative 0.41, comma 0. That is one of my x-intercepts. Okay. And then to get the other one, you do the same thing, but you're going to do the opposite. Second trace, 2 for 0. And then for this point here, my left bound is going to be anything that's above it. And I'm going to put my cursor anywhere above it and press enter. I'm going to go to the right bound, but instead of above, it's now going to be below. Right there. It doesn't matter where you put it, it has to be below. Press enter, and it says guess, you press enter again. And then here's your other one. So it's 2.41, comma 0, and that's your other root. 2.41, comma 0. Now, let's say if you want to find out what will be the vertex. Vertex for this case is going to be the maximum. So to get it, you press second trace, and then the maximum is going to be 4. So go to 4. And the left bound is going to be, if this is the vertex, the left bound is going to be whatever is the left side of this parabola. The left side of the vertex. So left bound is going to be here, and it doesn't matter where you put it. You press enter, and then you're going to go right down, put your cursor anywhere on the right hand side, press enter, and then press enter again. And there you go. Well, this one is not really 1, but it's close to 1, so you just round it up to the nearest whole number. So this would be 1, 2. Now, if you do this in the minimum, you do the same thing, except it's going to be same thing, left bound and right bound. All right, so there you go. There's my vertex, my roots. Now let's find out what the domain is. The domain is, obviously, it's going to be all real numbers. Because you have the arrows here, that means it's going to be continuous. And it's going to be all of the negative numbers and all of the positive numbers. So all real numbers. The range, we have to look at that from the lowest point of the graph to the highest. Well, this one here, that is, you have the arrows that goes downward. That means it will start at negative infinity. We do not know where it ended. So we're going to say it's negative infinity to the highest point of the graph in the y value, and in this case it's going to be at 2. I'm going to put the bracket. Now another way you can write this is you can say y, because that's my y. The range is going to be all the y values. So it's going to be y is greater than or equal to 2. All right? So go ahead and do 2 and 4 and see what you get for that one.